In this video, we're going to learn how to graph a linear equation. And we're going to start out by doing it the most basic way, which is the one you usually start out with, and that's making a t-table and graphing points. But then we're going to look at certain patterns, and from those we're going to learn a way to do it much faster and easier than plotting points. So let's just start with y equals x. Now that's a pretty basic equation. By the way, I want you to be keeping in mind throughout this whole thing the basic format of any linear equation. You may have seen y equals mx plus b before. The reason this is so important in math is because it represents any linear equation. This is like a template where any linear equation can be expressed this way. So let's just look at how this relates to this. Well, it doesn't look like there's an m and a b here, but there actually is. What would m be? Well, x is the same as 1x, so the multiplier in front of x, m, is 1 in this case. What would b be? Well, you could say there's a 0 here. This is the same as y equals 1x plus 0. Okay, but for our purposes, we'll just think of it like this. Either way is fine. Okay, let's do a t-table. When you do a t-table, you put an x and a y, make a t, and then just pick some random variables or some numbers to plug into the variable x. And I'm going to do -2 and 2. Okay, if I plug in -2 for x, what does that make y? Well, it makes y -2 also. If I plug in 0 for x, y is equal to 0. If I plug in 2 for x, y is 2. Okay, well, let's graph these points. So I'm assuming you already know how to graph points. If not, there's tons of videos on it. But if you want to graph and by the way, think of these as ordered pairs, because that's exactly what they are. You can read them right off the t-table as an ordered pair. Okay, so if I graph the point -2, 2, that means I go to the origin, I go -2x's and -2y's. And there is this point. Now, if I go to the origin and I go 0x's and 0y's, I'm going to still be on the origin. If I go +2x's and +2y's, then there's my point. And you can see that this equation, y equals x, forms this on the graph. Okay, let's do another one. Now I'm going to do y equals 2x. And we're going to do a t-table. And I'm going to just do -2, 0, and 2 again. You could put in, whatever random points you want. Okay, if x is -2, -2 times 2 is -4. If x is 0, 0 times 2 is 0. And if x is 2, then 2 times 2 is 4. And when I graph these, okay, according to this, I go 2x's left and 4y's down. So 2x's left, 4y's down. Then I'm at the origin again, 0, 0. Now I go 2x is positive and 4y is positive. So that's going to put me here. And there is my graph. Okay, pretty crappy straight line, I know, but you can see that it's correct. Okay, again, how does this relate to y equals mx plus b? Well, m is 2 in this case. It's multiplying every x I put in there by 2. Well, what is b? Well, b is still 0. So it doesn't need to be there, but I want you to think of this as, okay, the b value is 0. I want you to be able to look at any linear equation and name what m is and what b is. Okay, now before we move on, I want you to see something here. M is the most important part of a linear equation. So let's talk about what M is. M is the slope of the line. Here, notice that M is 1 in our first equation here, a slope of 1. Look at the slope here. It's perfectly diagonal. For every x I gain 1 y. Gain an x, gain a y. Gain an x, gain a y. And so that keeps me on the line. But look at this slope. This is rising twice as fast. Since x is getting multiplied by an m value of 2, a slope of 2, for every x I gain, I go up 2 y's. Gain an x, go up 2 y's, and so on. And that's how the slope works. So let's talk about this 1, the slope, the m. Okay, m equals 1. But whenever you have an m that is not a fraction, make it a fraction, because that's the only way the slope makes sense. Let me get a different color here so that it shows up on the white. Okay. And remember, rise over run. The bottom part of this fraction will always give you x movement. We call that delta x. And the top is y movement. We already looked at that. We gain a certain amount in x, and what does that do to y? Does it make y gain? And if so, what is the amount that it gains? Okay, well, this is a positive 1 and a positive 1, so x movement is horizontal. For every x I gain, I'm going to go up 1 y. This always happens. So let's go on the line here. Let's just look at this point. Okay, if I gain an x, I gain a y, and I'm right back on the line. Gain an x, gain a y. Gain an x, gain a y. Positive 1x, positive 1y. Positive 1x, positive 1y. And look how fast I can get other points just by using the slope. Okay, what's m here? My b is 0. What's m? Well, m is 2. Okay, this is not a fraction, so we need to make it a fraction. Now let's look and see if for every x positive we go, do we go positive 2 y's? Let's see if that's the case. Okay, well, let's just go to this point here. If I gain 1x, do I go up 2 y's? I certainly do. Gain an x, gain 2 y's. Gain an x, 2 y's. 1x, 2 y's. 1x, 2 y's. See how fast I can get other points? If I'm already on the line, I can use the slope m to quickly find other points, so I don't have to do a whole t-table here. Another thing I want to point out is that 2 over 1 is the same as negative 2 over negative 1. Okay, is negative 2 over negative 1 equal to 2 over 1? Well, think, a negative divided by a negative is a positive, so this is actually positive. 2 over 1 is 2. Well, 2 over 1 here is 2. This is the same as this. Remember this. Whenever you have a fraction, any fraction in the world, you can flip the sign of the top and the bottom both, and you still have an equivalent fraction, as long as you change both signs, not just one. Well, let's see if this holds true. According to this, if I go 1x negative, that's 1 to the left, I'm going to lose 2 y's. That means down 2. So let's go to a point here. If I'm on this point right here, if I go 1x left, do I lose 2 y's? Yes, I do. Lose an x, lose 2 y's. Lose an x, lose 2 y's. You can see this m and this m are the same m, and they give you the same exact line. So that can be pretty handy. Let's do another one. Let's do y equals 2/3 x. So what is my m and what is my b? Well, m equals 2/3, that's my slope. B equals 0. That's whatever number's out here. If there isn't a number, well, there actually is a number. It's 0. Okay, now, so let's use the slope here. Actually, let's do a t-table first. Let's do the primitive basic way that we don't really want to do, but I'm starting out with that way to show you how much, well, to show you the patterns first of all, and show you how much nicer it is to just get one point and then use the slope. Okay, in this case, it's kind of more convenient to use -3, 0, and 3. If I plug in -3 for x, and you can verify it yourself, I'm not going to spend a lot of time on this, then y is going to equal -2. If I plug in 0 for x, well, 0 times anything is just 0, so y is 0. If I plug in 3 for x, well, 3 times 2/3 is just 2. Okay, so I'm going to graph these. This says -3x's, -2x's. So from the origin, -3x's, -2y's. I mean, not x's. Okay, -3x's, -2y's. Okay, then we have the point 0, 0. Then 3x's right, 2y's up. 3x's right, 2y's up. And there is our graph. Okay. But now let's look and see how the slope relates to this. We've got 2/3. Let me make it bigger here. Okay. And remember, the bottom is always x movement. So never forget that. X movement is on the bottom. Y movement is on the top. Okay. More correctly, it's delta x, delta y. That just means a change in x, change in y. If x changes a certain amount, what does that do to y? How does it change y? Well, let's see if it holds true that if I gain 3x's, I gain 2y's. Okay, so let's go to the line somewhere. Let's go right here. Okay, let's look at this point again. Is it true that if I go 3x's right, it makes me go up 2y's? Well, it is. 3x is over, 2y's up. 3x is over, 2y's up. See how fast it is to get other points? And if you say, well, what about the other way? Can I change the signs of the top and bottom? Well, yes, you can. According to this, if I'm somewhere on the line and I lose 3x's, that means 3x's to the left, then I'm going to lose 2y's. So let's go up here, this point, and if I lose 3x's, what does that do to y? Well, it makes y drop 2. Lose 3x's, lose 2y's. Lose 3x's, lose 2y's. So we can see exactly what this number m, the slope, does always, without fail, how it always describes the graph to us. Now I'm going to make a little change here. Let's do y equals -2/3 x. And I encourage you to stop a second and see if you can think how this negative is going to affect the slant, the slope of this line. Okay, well, let's do our t-table. And I'm going to use -3, 0, and 3 again. And I'm just going to do this quickly. You can verify that's actually going to change it's going to give me the same 2, 0, 2, except it's going to change the signs. And when I graph those, okay, according to this, 3x's left, 2y's up. So from the origin, always from the origin, 3x's left, 2y's up. Then 0, 0, and then 3x's right, 2y's down. So 3x's right, 2y's down. And there is the graph of y equals negative 2/3 x. Well, this is a negative slope. M is negative. Anytime the slope is negative, you're going to have a line that is falling from left to right. It could be really steep. It could just be barely, but it will be falling, reading from left to right. And we always read a graph from left to right. Okay, well, let's see how M, the slope, the x multiplier, let's see how that plays out here. Okay, now, one thing you need to be aware of, when you have a negative in front of a fraction, it can stay in the front, or you can put it on the top, or you can put it on the bottom. If you don't believe me, let me get some space here. We'll come back in a minute. So let's go down here, and let's just make up a fraction. Okay, we already know this is equal to -2, right? Is this equal to this and this? So here the negative was in the front, here I put it in the top, here I put it in the bottom. Are these all equal? Well, okay, this is already negative. 4/2 equals 2. A negative divided by a positive is always a negative. 4 divided by 2 is 2. A positive divided by a negative is a negative. And this is 2. These are all equal. So yes, these are all equal. So the thing I want you to remember is if you have any fraction in the world that's negative, you can choose to put the negative in the top or the bottom, or you can leave it on the side. That is always okay. So now that I'm going to look at this M, we don't want to leave the negative on the side because it's not very intuitive that way. It will make more sense if you put it either in the top or the bottom. And let's see if this slope accurately describes this line. Because according to this, if I gain 3 x's, I lose 2 y's. And according to this, if I lose 2 x's, I'm going to gain 2 y's. Let's see if both of these are true. Okay, so I'm going to go somewhere on the line. Doesn't matter where on the line. This will always work. If I go right 3 x's, I go 2 y's down. I can keep doing that. I go right 3, down 2. Right 3, down 2. Let's look at this one, which is the same thing as this, but it helps us go the other way. According to this, if I'm on the line of this equation, if I go 3 x's left, I go 2 y's up. So let's go here. Let's go 3 x's left, 2 y's up. 3 left, 2 up. 3 left, 2 up. 3 left, 2 up. And so they both make the same line. Well, now we're going to stop plotting points, and we are going to just graph using one point only in the slope. Okay, what I want to do next, this is just a copy of what we just did. I want you to see this. This was done by plotting points. Now we're going to do the same thing again, but we're going to do the method where we don't plot points. We get 1 point and we do the slope. So, step 1, get a point. Don't do a whole t-table, just get 1 point. Step 2, use the slope. That's all there is to it. Okay. So when you get a point, that means you're going to get an ordered pair. You're going to pick something for x, and here's what I want you to do. Whenever possible, use 0 for x because it's the fastest, easiest point to plug in. You could use 1 or 2 or -2, whatever you want, and you can get the same thing done. But why not use the number that is the friendliest number to plug in? What happens when I make x 0? Well, x times whatever else is here is just 0. that makes y 0. So we have a point now. So put the point on there. And now I'm going to do the slope. Well, the slope is 2/3 or -2 over -3. Okay, so I'm going to go to the origin, and this says if I go right 3, I go up 2. Okay, right 3, up 2. Right 3, up 2. According to this, if I go left 3, I go down 2. So left 3, down 2. Left 3, down 2. There's my graph. This is the same graph as this, but this was a much faster, easier way to graph the same equation. Let's do a couple more. So here my m is 3/4. My slope is 3/4. So what's the first thing I need to do? Well, I need to get a point, and I'm going to plug in 0 for x. I call this the fast point. So it doesn't have to be the fast point, it can be any point, but use 0 if possible. It's so much easier. If x is 0, y is 0. Now I know I'm on the line, and all I have to do is do the slope. According to this, if I gain 4, I gain 3. So gain 4x's, gain 3y's. Gain 4x's, gain 3y's. Or if I switch both signs, the top and the bottom, I can lose 4x's, 1, 2, 3, 4, and lose 3y's. Lose 4, lose 3. That's how fast it is to graph this. Again, you could have put 1 here instead of 0, but then you said you'd have had 1 and then 3/4. Well, you know, that's not nearly as nice. Bottom line, just use 0 whenever you can. It isn't always possible because it depends on the dimensions of your graph and so on. Okay, let's do this one. What's my fast point? Well, if x is 0, 0 times this is 0. Okay, well now I need to put the negative on the top or on the bottom. And all I have to do is go to my point, and according to this, if I gain 2, I lose 1. Gain 2x's, lose a y. Gain 2x's, lose a y. According to this, if I lose 2x's, I gain a y. So I lose 2x's, gain a y. Lose 2, gain a y. And I have now graphed this. Okay, on this one, my fast point, first of all, what's m here? Well, m is 2/3. What's b here? It's +1. Up to now, b has been 0. There hasn't been anything other than nothing out here, and so we know b is 0. Well, now I'm going to graph this, and my fast point, I'm still going to make x 0. What is y equal to when x is 0? Well, if I make x 0, I have 0 times 2/3. Anytime you make x 0, this entire term disappears, always. And what does that leave y equal to? Well, it leaves it equal to 1. And so now we have a point. I go to the origin, I go 0x's, and I go 1y positive. Now we know we're on the line. Okay, now I'm going to do my slope, so I can do 2/3 or -2 over -3. So according to this, if I go right 3 up 2, right 3 up 2, right 3 up 2. According to this, I go left 3 down 2. So left 3 down 2, left 3 down 2. And there's my graph. Okay, that number right there is called the Y-intercept. Why? Because this is the y-axis. This is the x-axis. The y-axis is getting intercepted by the graph. It's getting cut by the graph at 1. And where did we get that 1 from? It was right there. Notice if I make x 0, well, this is the x number line. Negative x's, 0, positive x's. If I make x 0, that lines me up right here. So whatever y is equal to is going to be where the y-axis gets cut. So that is one thing that you can remember. Your fast point is just going to be the y-intercept. Which is b. This is this number right here always. So let's look at the next one here. What's my fast point? Oh, I forgot to put an x in there. Okay, if I make x 0, what is y equal to? Well, the only thing left is this number. This term went to 0. That means y is equal to -2. If I graph this point, I go 0 x's and -2 y's. There is my y-intercept right there. It's always this number. It's always b. Always remember b equals the y-intercept. Okay, so my fast point is always the y-intercept. I make x 0. Okay, so this point is always 0 and whatever b is. That's this number. You make x 0, this is what the y coordinate is going to be. Okay, now, according to this, I can either do a slope of -2 over 5 or 2 over -5. So I'm going to go to this point that I know is on the line. And here it says if I gain 5 x's, I lose 2 y's. So 1, 2, 3, 4, 5, lose 2 y's. Or according to this, if I lose 5 x's, I gain 2 y's. So 1, 2, 3, 1, 2, 3, 4, 5, 1, 2. And there is my line. By the way, I don't know if I have mixed up saying x's and y's throughout this video. I hope not, but hopefully you know what I mean. Looking at the context, if I have said stupid stuff, I get absent-minded and I do stuff like that sometimes. Okay, 2 more, and I'm just going to do these fast. Okay, what is my fast point here? Well, it's going to be 0, -1. If x is 0, then y is -1. It's going to be the intercept. So really, you could just get used to looking at this number out here and saying, okay, I know right there I'm on the line. I'm just going to do the y-intercept immediately because that's what your fast point is. According to this, I can either do this or this. So right 3, down 1. Right 3, down 1. Right 3, down 1. According to this, left 3, up 1. Left 3, up 1. Left 3, up 1. I'm done. Okay. So according to this, my y-intercept is -2. This is my fast point, 0, -2. My slope says, okay, remember, if your slope is not a fraction, you have to make it one. So I can either use 3 over 1 or -3 over -1. If I flip both the signs, I'm good to go. Okay, according to this, right 1, up 3. Right 1, up 3. Right 1, up 3. According to this, left 1, down 3. Left 1, down 3. I am done. So if you want to plot points, you can, or you can do the fast, easy way, which is get one point, preferably the y-intercept, and then just do your slope. And it's way faster and easier.